Good job.
That's why I want her say it louder.
The emission of electrons due to heat.
Okay. Exposure switch is fully pressed, so this is actually you pressing the button of voltage. Huh? Yeah, X-ray. The voltage difference is created between the cathode and anode. The electrons are attracted to the positive charge and move from the cathode to the anode. So right here. So basically, look, this is showing the rotating anode. So what's good about the rotating anode again?
It doesn't heat.
Okay, good. And what's that called again? When it goes around the circle, is it the focal spot or
Focal track.
Focal track. Thank you. Okay. Did you have anything else to add, Mr. Phung?
So just curious, of those who have, so for you who have been in clinic and have worked with a normal X-ray machine or a portable X-ray machine, has your tech let you expose X-rays? Has the tech let you be the one to push the button?
Yes.
Yes.
All right. Has anyone tried just pushing the button down halfway before?
Mhm.
I did because
Yes.
I
I
got
got
in
in
trouble. To press it. She was like, press it. I'm like, okay.
I got
Or
in trouble.
You got in trouble?
Well, I didn't. She said to press it, and she didn't tell me like how long. And then like afterwards, she told me that like you're supposed to hold it down, and it was basically on the screen. All the numbers are supposed to pop up,
Mhm.
and then I can let go. If I like press it down really quick and and release it really quick,
Mhm.
if the numbers don't show up, like I think it was like mass and like KVP and all that stuff.
Mhm.
It doesn't take. It still takes the image, but it's not like, I guess, all the way like a proper
Right, you
like
get
take.
like a partial exposure.
Yeah.
Let's see, who said that they did it halfway? Reagan?
Yeah, because Eric was trying to show me, he was trying to show me how some machines, like they have like, he was trying to explain like metal gets stuck like inside of them, so you have to turn up like the KVP and stuff. He was going way too far in depth. I wasn't there yet, but that's what he was trying to show me, that like the more you use the machine, or basically like the longer you have it like exposed, like it'll be off a little bit or something like that. Yeah. So I thought I was doing something wrong, but he was just making me halfway press it and then let it go like over and over and over again. And I was like, I feel like I'm doing something really wrong. But there was nobody else in the room for that.
Okay. All right. Mansi, did you say you also did that?
Well, I didn't really take the picture.
Mhm.
I just had it like halfway, and then they were like, press it. Don't be afraid to press it. I'm like, okay. And then I pressed it more, and then it beat.
All right, very good. All right, so remember, our X-ray switch is a dead man switch, right? It has 2 levels. So you press it halfway, like it says. You're warming up your tube. You're spinning up that rotor. You're getting those electrons ready, but nothing is moving, or no electrons are going across inside the tube, right? The electrons are just sitting there. The rotor is just spinning. Once you push it all the way down, that's when you activate your voltage. You create the difference, negative, positive, electrons jump across, and only then do you produce X-rays. Right? So you could leave it down halfway for a while, right? You could leave it like that for 2-3 seconds and not do anything. Rotor just keeps spinning, electrons just keep sitting there. Right? But you do that too long, you're going to cause issues with your tube. So don't hold the rotor for too long. Make sure that you either let go or finish your exposure. What cases?
I think she had a question.
Oh.
No, we don't. Oh, I'm sorry. I thought
So in what situation do you think it would be useful to hold a rotor like that?
Old folks, they can't stand too long. Someone who's just like, maybe like not steady, and when you're doing the exam, so you just want to get on there a little bit and hurry up.
So if you're on the rotor, how would that help you with the exam?
Just
Wait a minute, what was your question?
So in what situation would you want to hold the rotor halfway?
While giving the breathing instructions?
Yeah, giving the breathing first one, the old person or something.
All right, so breathing instructions, right? So if you're doing proper breathing instructions, you should not need to hold a rotor, right? You should be able to hold your breath, you push it, it warms up, and it shoots normally.
Wait, wouldn't it be for like people who you can't give breathing instructions, like kids and like people who are
Yeah, I
that
was
you
just
have
about to say,
watch
don't
them
moving
actually
around
breathe?
and all.
Very good. So for patients who you cannot give breathing instructions to, You hold a rotor, it spins up, you watch their chest, you watch them breathe in, and as soon as they breathe in, you push it all the way down, electrons shoot across, X-rays fire. So you don't have that waiting period anymore. Right? So very good. Great job. And so start to kind of connect some of this stuff here back into what you see in clinic, okay? They talked about it briefly in Intro to Rad Tech.
Only push the button if they
Alright,
like they
thermionic
need it, like the
emission
kids.
occurs when the filament is heated to incandescence.
Incandescence.
Incandescence?
Incandescence.
Okay.
Okay.
You're actually trying to act
Look
it
at
up,
there.
but-
Look at there.
White hot.
White hot. Yes.
The electrons boil off and the focusing cup forms them into a cloud around the filament called the space charge, self-limiting in size, space charge effect. Mr. Phung, I want you to explain space charge again to me.
Space charge. So, space charge is just that area or that cloud of electrons around the filament. Right? So you've got this kind of like negative area around the filament. What keeps the electrons or what keeps the space charge in place around the filament? Focusing cup. Very good. Why is the focusing cup able to keep the electrons in place?
That's their job.
They have a stronger negative charge.
Because the focusing cup has a negative charge.
What's that called? Ooh, I should have put that on.
Yes, what is that called?
What is one called?
That, what's it called?
So,
I'm trying to give like an example of what it is, but not.
so what is that effect called where something negative, something strongly negative, can push away other negative objects?
The voltage.
Repulsion, specifically.
Static.
Good.
We talked about
That's
that.
right.
Electrostatic repulsion.
Electrostatic repulsion. It should have been in the first part.
Yeah, that's a long time.
Repulsion. It pushes away, repulses.
Last slide. Alright, quality control, extending tube life and heat units. Do you have to do math? Yes.
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 Alright, the tube life can be reduced due. Oh, wait, why did this go black? I changed this.
Change it back real fast.
So I can see.
Yeah.
This is what he was trying to explain to me, Eric. But this was too it was too soon.
Heat units, yes.
too soon.
Yeah.
Mhm. So what you were doing was warming up the tube in that case, I believe. Did you do it like first thing in the morning? Or did you do it?
It was kind of early, yeah.
It's kind of early. Right. So here, as far as warming up the tube goes, the idea is that, let's say you've got a cold anode, right? It hasn't been used for a while, right? Hasn't been used in 10 hours. And suddenly you blast it with electrons, you blast it with X-rays. And you just heat it up really fast. What happens when you heat something up really fast?
Like a break.
It breaks, right? If you've got like a cold glass and you pour hot water into it, right? What happens to the glass? It breaks, it explodes. So it's not healthy for things to undergo rapid temperature changes, right? So the idea is that at the beginning of each day, or whenever the tube has not been in use for a while, we are going to warm up the tube, get the tube up to a warmer temperature so that when we shoot actual patients, right, with actual exposure factors used for patients, we don't destroy the tube due to that sudden increase in heat. So at the beginning of each day at the clinics, because they haven't been in use over the evening and over the night, normally what happens is that the tech will go in and they will do some warm up exposures. You just hold down the button and it goes beep, 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 beep for like 30 seconds, just to heat up the tube and get it into a state where it's ready to shoot without destroying itself.
when you guys go into your clinical sites, make sure you guys warm up the tube.
Mm-hmm. Yes. Ask your techs how to warm up the tube out at those outside clinics if they don't tell you how to do it themselves.
Okay, so the tube life can be reduced due to heat, frequent use of high exposure factors, use of long exposure factors, overloading the filament. Heat is dissipated by oil. There is a limit to how quickly heat can be removed from the tube. The amount of heating the tube can take is measured in heat units, HU. And do you need to know this formula? Yes. But Mr. Phung, don't you want your
Yes.
test at most of the time it's just like you multiply everything that's on the question.
Yes, with 3 unit things, you just multiply everything that you need.
So what's the name of this
Thank you.
formula?
So this is gonna be the heat units.
So I'm assuming you're gonna give us questions that have unnecessary information.
He could, but most of the time Mr. Phung he's actually nice on our test. I don't know if he's gonna be nice on y'all. On us, he's nice. He just gave us
more, right, Mr. Phung?
He just gave us KVP.
Maybe I can't say that. Is that true?
No comment.
We don't plead the fifth.
Aliyah, S stands for second or S stands for single phase? So it's not, then what are these dots? The
So I didn't, sorry, let me, guys, don't be packing up. I see what Mr. Phung be saying, folks, they already packing up. Let's finish it before y'all leave. So, we have KVP,
It's just,
we have MA, we have seconds, and then we have correction factor, that's what the C is, right? So these are all your correction factors. So do you need to memorize these right now?
I'll tell you.
Yes. Oh, you're making them memorize right now? Ooh,
Yes,
sweet.
you do need to know your correction factors. I will not give you your correction factors. You do need to memorize your correction factors, yes.
So single
Friday.
phase is 1, 3 phase, 6 pulse is 1.35, 3 phase, 12 pulse is 1.41, and then high frequency is 1.45. So yes.
Well, just remember, the 6 is the lowest, 35, 12 is 41.
How long do you need these numbers memorized for?
Just for you?
Forever. This one is Friday. For the registry. This one's Friday.
Did I ask your class about these correction factors 1 year after you learned them?
You always ask me about them.
I did, didn't I? Yes. Okay, so you do need to know your correction factors. If there's a question that asks you to calculate heat units, it will give you something like using 80 kVp, 32 mass with a 3-phase 12-pulse generator, what are the heat units produced? So 80 kVp, right?
Okay.
32 mass.
Okay.
That's MA and time together, right?
Okay.
Gave you both of them all together. Correction factor, 3-phase 12 pulse, 1.41. So you just multiply all of that together. Now if I give you tube angle, do you multiply that in? No. If I give you grid factor, do you multiply that in? If I give you filtration, do you multiply that in? If I give you SID, OID, do you multiply that in? So what do you multiply in?
KVP, mass, and
Correction factor.
Good. KVP mass correction factor. That's all it is.
If y'all want something to help you guys remember this, I can help you guys. So like Charles said, single phase is 1, right? So you need to just memorize high frequency, which is 1.45, right? The one that goes behind it, which is the 3-phase 12 pulse, is 1.41. So just remember it goes 1, and then this one's less than this one. So it's 4 is less, 3 is less than 4, right? So then it's 3, but then you have the 5 right here. So there's 35 and 45. So you remember that, and then there's 1 and 1, and then there's 2 4s. That's how I remember it.
Yeah.
See what I'm saying? You got what I'm saying, Mr. Moon? I think I did.
Yes.
Help me.
Little tricks. I mean, they
Oh, great question. What exactly is correction factor? You have different types of generators. These generators provide power at different rates. Some are more efficient at providing power. which means you have more power over time. The more power you have, the more heat you produce. Therefore, you need to account for the extra heat being produced. So single phase, the weakest generator, multiply by 1. High frequency, the strongest generator, you need to multiply by 1.45 because it's more powerful, more efficient than single phase.
Makes sense.
All right, great job.
We're out of here.
All right, great job today. Great job. Don't forget, Wednesday